right, so question 16. Yes.
Oh, I just wanted to pick.
Oh, you want to answer? All right.
Yeah.
So what do I need to do?
Okay. So you have to take the 6x minus 9 plus the 4x plus 4 and equal it to 75.
Okay. So let me start this stuff.
Sorry.
Oh, you're fine. All right, so me putting these videos together, recording them, we'll do it for a week, 2 weeks, and then we'll revisit and see, has it been beneficial, or grades going up, or do we like it, is it useful? Because it is time consuming for me to do this, so I'm not going to do something that's futile and doesn't make a whole lot of sense if we're not using it. But on the second part of that, it's not to take away from you having to do notes in class. It's not taken away when we go over questions like this and just sitting back, chill, and say, hey, I'll look at this later, okay? Because it's so much more informative when you're paying attention now and learning now. And then the videos are meant to be secondary to the course. Does that make sense? All right, they're resources. They're not to supplement, not to replace the course. They're meant to supplement the course. All right? So still taking notes, that kind of stuff. And if we quit doing that, collectively, I will quit making videos, okay? Because I think doing that will hurt you if you take that route. So what she said is that we're going to take the two components, okay? Take this small angle CBA, okay? So 6x minus 9, okay? And then we're going to take the other small angle, 4x plus 4, because they are adjacent. Okay, and we're saying that when we add those two angles together, that should give us this total angle, right?
75.
And that total angle is 75. Yes.
I just don't want to go.
Go ahead.
Okay, and you take the 6x plus the 4x, which equals 10x, and then negative 9 plus 4 equals negative 5. And then you equal that to 75, and then add 5 to both sides, and then get 80, and then divide it by 10, and x equals 80.
Good. Okay. So solving that. Not the only way you could have done it, but probably the most efficient way you can do it. Okay. The next thing they want to know is what is angle ABC. So make sure that measurement of angle ABC. So they want a number back. So we come find ABC, this angle over here, and we're going to just plug in 8 to that expression. So what's 6 times 8? 48 minus the 9, 39 degrees. Does that help?
Yeah.
That help? Okay.
When I was doing it, I always got some number that didn't buy correctly. That didn't give me an even number, it always gave me decimal.
Did you equal your things together?
Let's see.
I did both ways. I subtracted 4 and got 2x or something like that. Twice.
Let me look towards, when we're done here, I'll pull yours up and see your specific problem. I'm not, that could happen. I'm not saying, a lot of times they do give you whole numbers, but there's nothing wrong with getting back x to be 2.2 or something like that. Those things can happen. I'll take a look at yours individually. The next part, I guess, asked, I found ABC. The next part asked to find DBC. So then you just plug back in to that expression. If you find that one individually, you should be able to find the second one individually. Okay? Do you have a question?
No, it wasn't a question. I actually wanted the answer as well.
Okay. All right. So that's 16. Anybody want to see anything else? Any other problems in there? Nothing?
Okay, I'm not really sure what number it was. It was towards the end. It had yeah, that one.
Okay. This is a really good one because you're going to see this again soon. Okay. But it says use the diagram on the right. So when they tell us to use a diagram, make sure that we understand, just like I said yesterday, do not take anything for granted. Okay. Don't make assumptions. Only use the information that they're telling you explicitly. Okay. And in this case, they're telling us right now with this notation, because that's 2 markings in it and that has 2 markings in it, those things are congruent, right? Okay. It is also telling us whether we need it or not, this distance and this distance, because they have 1 marking, they are the same. Is that okay? All right. Now what I want you to understand though is, this red segment A to D, is that red segment equal to E to D? No, because they have 2 and 1, right? Right?
I got this right, but I don't remember how I did it. But would you take 14 plus 2y minus 6 is equal to 28?
Well, let's highlight the parts. So they give us AD and they give us AC, right? Those are the components they provide us. So what I like to do is just, because I think it makes it a little bit easier to just visualize this. AD is that, and then C is down here. I know it's not written there, but AC, I'm going to line that in red, so we'll come over here and do that in red. So we're looking at that blue segment and we're looking at that red segment. And every time you do this, regardless of the content you're dealing with, so here we're talking about segments, eventually it might be angles, eventually it might be something completely different. But you want to take the measurements that they give you, and they're giving us 14 and 2y minus 6, right? Those are measurements. Now 2y minus 6 is arbitrary. We don't necessarily know what it is until we know what y is, right? Okay. But we look at the shapes that we are identifying, okay? The red one and the blue one up there, and we start to see, is there a way that we can relate them, okay? And the goal is, a lot of times we want to set up equality, but we know those 2 things are not equal, right? The red one and the blue one are drastically different, but there is some type of relationship with them that we can develop an equation for. I'm going to try somebody else. Thanks, though. Good.
The little lines say that segment AD is equal to BC. So you just do 14 times 2, which is 28, and you do 2y minus 6 equals 28.
Good. So these little hash marks, the double hash marks, tell us that AD is the same thing as D to C. All right. So those are equal. Okay. So what we're saying here then is if I go ahead and take the 14, which is this A to D, and double that, that would give me that entire blue segment, right? So now I've got that entire blue segment, which we're saying is 28. Okay? That entire blue segment is now the exact same thing as that entire red segment, right? And we said the entire red segment is 2y minus 6. And now we've developed the relationship. Now we set them equal to each other. We solve for y that way. So we get what? 34 is equal to 2y. Y is 17. Okay? So it says type an integer or a decimal. So integer tells us that it could be 0, 1, 2, 3, 4, 5, all the way to infinity, and their opposites. Or a decimal could be something like 2.8 or 17.4 or something like that. Okay? Make sure that you pay attention. I think the first thing you ever do before you type something in right there is that you read this stuff in parentheses in blue. Sometimes it's red. But remember, they're not going to write something or type something that was a waste of their time because they were employed by somebody for their time. So this is important information here. Okay. Also, a lot of times that can be very useful in kind of, if it says type an integer and you did work, you got a fraction, you got like 17.5. What's that tell you? You're wrong, right? Because they're looking for an integer. They're saying that all the math you do here, the only types of numbers you can come back with are integers. You got a rational number. You got a fractional value. You should know then that you've done something wrong. You can go back through and rehash your work.
When 17.5 will be right because it also has square decimal.
Well, in this case, yeah. Okay. But if it didn't say that, if it just said type an integer and you found 17.5, then you know you've done something wrong. Okay. So those directions vary from time to time. I'm assuming they ask you then maybe, do they go further with this question?
Yeah, it says 2.
Alright, so we found y is 17. Alright, and they want to know AC. So obviously we've already found AC, right? We had to double that 14 to get AC to begin with. So we can find it to be 28. Or you can plug it 17 back in to find that it's 28, but and that's the last part. Okay. Huh? Oh, I read that. Did I read that? No, so they're asking DC now, right? So DC 14. That's a lot of stuff here. All right, so there's the next question. What would we call this? Just a vocabulary word we talked about. What would we call this segment in regards to AC? What does it do to AC?
Bisector.
Okay, it's a bisector. It's a segment. So that red segment is a segment bisector of the black one, right? Okay. What about that one? It's terrible. What about that segment in regards to E to B? Yeah, segment bisector again. Okay. Now I have no issues with you just calling it a bisector, but we are going to start talking about how we can bisect angles as well. So in general, when I say EB is a bisector, it'd be nice to know what type of bisector is it. Okay, is it bisecting a segment or is it bisecting an angle? Okay, the idea, the definition of those things is very similar, and the fact that they cut things into two different parts. But it's always nice to know what is getting divided.
I have a question.
Yes.
What's the difference between intersecting and bisecting?
Intersecting is something like this. Well, let's phrase it this way. It's the same idea as if I said a square is a rectangle, but a rectangle is not a square. Maybe you've heard that before. What we've got when we have intersection, I'm trying to find you there again. When we have intersection, it does not specify on the relationship of how things are intersecting. Okay, so it doesn't necessarily mean that we're going to be cutting in half. So if I have, let this load. If we have that segment there, and let's just go ahead and find the midpoint. So this will, I can just click on that segment and it'll find the midpoint for me. And now I just put in some arbitrary line. Doesn't really matter. Okay, those two things are intersecting. Intersecting just means basically cross, right? Okay, but when I move that line, so it goes through there. That line is still intersecting. Both those segments, or the segment and the line, are intersecting. But now that line is bisecting AB. So bisecting is a type of intersection. Does that make sense? It's a specific kind of intersection, and it's when we develop two parts that are equal. But intersecting in general is just somewhere the shapes share some coordinates. They share some points. That's a good question. Any others on here you guys want to talk about? Confused? Struggle with? We're good?
On the clock hands,
Okay.
I wasn't sure how to, like, find it without having a picture.
Okay, okay.
projector.
Let's do one.
It's like 12.
12. Now I don't, and it's all dependent on how they,
If it's like 9 or
Yeah, it's like way before.
come on Tyler.
I know, right? I just told him.
Okay, so they're going to get, I don't know, let me just regenerate it. So 7 o'clock, 7 o'clock, 5 o'clock, 9 o'clock. So they're giving you basically whole hours, right? Okay, because, and we do this in a trig course, and talk about this, how it changes. Like in a trig course, we might say, what's the angle between the hands when it's 8:41? Okay, and so what happens when my minute hand goes through to 41? What's my hour hand starting to do? It's starting to move as well, right? Okay, so like at 8:30, my hour hand is halfway between 8 and 9, right? But at 8:41, we talk about how much more that hour hand has moved and where the minute hand is and all that kind of stuff. So these problems can get much more involved. But the foundation of the problem is to initially think of a circle, okay? So I'm going to go to GeoGebra again. Let's go. We've got our clock, right? Okay. Let's do it this way. All right, so that's our clock, right? How many degrees are there in that circle? 360. Okay. So what happens then? How many on a clock? How many hour markings are there? 12. So let's just deal maybe with, so 12 is maybe. I apologize for this. This is a pain in the butt because Windows 10 doesn't like to work with the Smart Notebook stuff, because the Smart Notebook stuff is from like 1991. So sometimes I have to close that and start back up. So I'm sorry I had to go back and forth. But we got 12 o'clock here, right? Okay. We'll have 3 o'clock here. 1 o'clock, 2 o'clock. What do you know, and I'm just going to do that first quadrant here, but what do you know about the number of minutes from 12 to 1? It's 60. So what about the number of minutes from 1 to 2? And what about from 2 to 3? 60. So between any two consecutive hours, the number of minutes should be the same, right? So the number of times that minute hand moves should be the same. So what we're trying to say here is between any two hours, consecutive hours, the rotation of your minute hand should be the same. So if I draw in like my minute hand there, and then talk about how that minute hand can now become, so it'll start here and then it'll rotate there, right? Maybe. And then here, and it'll rotate there too. I apologize for that. And then you can rotate to 3, correct? Now the goal is to recognize that rotation from 12 to 1 and from 1 to 2 and then 2 to 3, that distance, or that span or that angle should be the same as that one, which should be the same then as that angle, correct? Okay. So we could do this with the whole clock, but I don't think it's necessary. How many degrees would there be between 12 o'clock and 3 o'clock? It'd be 90 degrees. And how many separate angles have we found inside it? 3. So what is each one? They're all got to be the same. What does each one got to be? 30 degrees. So between any two consecutive hours, we've got 30 degrees. Okay. So now what they're asking us is if it's 8 o'clock. So you've got a minute hand. At 8 o'clock, you got a minute hand on 12, right? And then you've got, there's 9 o'clock, so there'd be 8 o'clock, correct? So now we're looking for the angle between the hour hand and the minute hand. So this here would have been how many degrees? 90. And this one here is how many degrees? 30. So then collectively from 8 o'clock to, or from 8 to 12 on the clock, we'd have 120 degrees. And then, so if they said 7 o'clock, basically you add another 30 to that, right? Okay. We should have something, the way we're going to do things, we should always have something. If it's 12 o'clock, sorry, 12:30, I guess that wouldn't work, would it? It's 12:30, that hand is going to start, this hand up here is going to start moving a little bit that way. So that angle is not going to be exactly 180. Okay, so we should have things that are less than 180 degrees.
If you have the clock, 12 to 6 is 180, and then 5 would be 150, and just move on both
Yes.
sides.
Yep, that works. Does that answer your question? All right. Does anybody else have anything else you want to talk about? Any other problems that they struggle with, or through the whole week? Anything with segment addition? Anything with vocabulary? Or anything like that you guys want to talk about? You feel confident? Sure? All right. What I've got for you